In this video, we'll be looking at the dot product in detail. The dot product is an operation that maps two vectors in n-dimensional space to a scalar. In this video, we're trying to prove that vector A dot vector B is equal to the magnitude of length A times the magnitude of length B times the cosine of the angle in between the two vectors, represented by theta. The definition of the dot product, with vector A being defined as dimension A1, dimension A2, all the way to dimension AN, and vector B being defined as dimension B1, dimension B2, all the way to dimension Bn, the definition is vector A dot vector B is equal to A1 times B1 plus A2 times B2, all the way to AN Bn. And with that, we now need a mini-proof to prove the dot product. In this mini-proof, we're trying to prove that the magnitude of the length of the vector is equal to the dot product of the vector with itself. So we need Pythagoras' theorem, which states that the hypotenuse squared is equal to leg 1 squared plus leg 2 squared. So the magnitude of the length of the vector squared is equal to the first dimension squared plus the second dimension squared. It would work all the way to n dimension as well. However, for simplicity's sake, we just use 2 dimensions. Next, we go to the dot product, which shows that vector A dot vector A is equal to A1 times A1 plus A2 times A2, which is equal to A1 squared plus A2 squared, which is the same as the above. Therefore, we can conclude that the dot product of a vector with itself is equal to the magnitude of the length of the vector squared. Now for the broader proof. In figure 2, we have a triangle with vector A, vector B, and vector C, with vector C being equal to vector A minus vector B. We need the cosine law. The cosine law states that length C squared, the magnitude of length C squared is equal to the magnitude of length A squared plus the magnitude of length B squared minus 2 times the magnitude of length A times the magnitude of length C times cosine theta. As shown here, the magnitude of length C squared is equal to the dot product of the vector with itself. So we need to expand vector C squared dot vector C, which is equal to vector A minus vector B dot vector A minus vector B, which we got from here. Then with the distributive property, we write vector A dot vector A is plus vector B minus 2 times the quantity of vector A dot vector B. And now we have the equation using the cosine law from above, and now this. We have the left-hand side of the equation, which we got from the distributive property, and the right side of the equation, which we got from the cosine law. And then we expand it, and then simplify. So we have vector A dot vector A plus vector B dot vector B minus 2 times the quantity of vector A dot vector B equal to vector A dot vector A plus vector B dot vector B minus 2 times the quantity of the magnitude of length A times the magnitude of length B times cosine theta. We can subtract the dot product of A with itself from each side of the equation, and the same for the dot product of B with itself from each side of the equation. And then we can divide 2 from each side of the equation, and we are left with the vector A dot vector B is equal to the magnitude of length A times the magnitude of length B times cosine theta. Thank you for watching.